Our home plate for tonight will be play sheet 1.1. I have it over here. All right. And there will be tutoring. Today we're going to finish with the lesson 1.1, which is an identifying domain and range of functions. Our objective for today, I can identify the domain and range of functions. So you know the concept will show on, please? Functions, that is correct. Get your Cornell note ready. You do need a Ferrer model? No. So, just to recap from what we covered yesterday. Yesterday we covered some vocabulary, yes. We covered ordered pairs. I gave you guys an example. We covered the relation. I gave you guys an example. We covered the domain. I gave you guys an example with set notation. And then I gave you guys the range. Same thing, examples and examples. Right, Jake? You good? Yeah? Yeah, we're gonna go over that. So, also, I showed you how to represent the range using a table. You guys remember that? Then I graphed those, or that data into graph, and then at the end I showed you using matching diagrams. So, functions. Think about it without looking at your notes. What are functions? Don't say it out loud. In your own words, what are functions? Tell your neighbor, please. In your own words, what are functions? Tell your neighbor. Without looking at your notes. All right. So, who wrote something in regards to one input for every output, or one output for every input? One output for every input, or something like that? Who wrote also somewhere in the definition a relation? Yeah. Functions are relations, is that correct? All right. So you should have something like this. A relation with exactly one output value for each input value. Okay. So think about it. A relation. Can you picture that in your noodle? Okay. Write a relation right here, please. Write a relation, please. All right. Let's see, Ramon. Relation, go. 1, 2. 3, oh my goodness. Oh my goodness. Hands if you agree that's a relation. Yes, that is correct. Is it a function? Let's check. 1 only has the number 2 as an output, so it's only one output, okay? 3 has number 4 as an output, that means only one output. 5 has number 6 as an output, so it's only one output. Now, let me give you another coordinate so that you can actually confirm to make sure that it is a function. Here goes. 1, 2. All right, tell your neighbor why I put this point in order to confirm that it is a function. All right, Xavier, why did I put that extra one? Yeah, so if 1 is the input and 2 is the output, the second set, or the second time 1 comes up, 2 has to be the output also, okay? All right. So this is a function, yes? All right. Carla, am I going to take that away? Are you sure? Yeah, it's like, hello. Didn't I explain this already? This is my domain, my goodness. Hombre, parece nuevo. Alright, therefore, look at this. I want you to write, focus please, I want you to write this relation over here in the non-examples, but only change one number to make it a not a function. Once again, Copy this relation over here, change one number so that it won't be a function. Do that right now. Hurry up, please. What is, which number did you change? The 3 to a 1. So she changed this one to a 1. So then her new relation is 1, comma 2, 3, oh, you said 1, my bad. 1, comma 4, 5, comma 6, and 1, comma 2. All right. These are still the same, so that's cool. This one in itself has its own output. But this one says that 1 has an output of 4. So let's see. 1 has an output of 2, but now it has an output of 4. How many different outputs does it have? 2. That's why this is not a function. Everybody got it? All right. On the examples, think about an equation in function form. An equation in function form, and write it in there, please. Equation in function form. Equation in function form. All right. Show your neighbor, have them copy yours to make sure they have something similar to you. All right. We got it? All right, Damien, go. +1? Okay. Hands if you agree that's in function form. That is not in function form. We said this is what it was before. What is function? Take this one, guys. Tell your neighbor how to make this in function form. Let's see. How about Damon? F of x equals 2x plus 1. What's that? So, Carlo, the difference that this one is the same as this. However, this one is telling us that this is a function. Yeah? Okay. All right. Do a hashtag. A good hashtag, please. A good one. Focus, please. And the hashtag, I'm going to ask maybe Damien again, yeah? Let's go. Damien, go. Oh, my goodness. Did you guys hear that one? Hashtag function. Another hashtag. What do we call them? Tanner. Go, Tanner. You're hiding back there. What's going on? Hashtag what? What is it? 141. Damn. I have a good one. Watch. Hashtag. Bam. Anyways, you guys get the idea, yeah? Alright, so we're done with our prayer model. The other vocabulary that we covered for yesterday was intervals. So remember intervals. Yes? It's a part of a graph. From there we covered two types. Finite, which means that the endpoints end, and to indicate that they include the endpoints, we use what kind of symbols? Brackets, right? The other one is infinite. That means that it keeps going either in one or two directions. If it does, what symbol do we use? We use parentheses. Okay, we got it? All right. From there, we went to this. Remember that? Yeah. Okay. Therefore, since you showed me that you were at 5 and 4s yesterday with this, I'm assuming that for the first 4 problems on the home plate, you got it all correct. Get your home plate in front of you. Let's see if it's true. Yeah. All right. Y'all ready? Here it goes. Number one. It says, write the interval shown on the number line as an inequality. That's the first thing that we need to write. The second thing we need to write is set notation. Do we know how to write set notation? Yes. And the third, we need to write interval notation. All right, so I'm going to start with my inequality. How do I write an inequality? I need a variable and a dividing point. So I got x, and what's my dividing point? 5. Okay, so far so good? All right, so to find out which direction the arrow points, I'm going to test the point, any point from in here. I'm going to test number 6. Which one is greater, 6 or 5? 6. So if this was on a scale, that means the 6 is heavier, so it's going to drop like so, so the arrow is going to point in that direction. Also, since this is a solid point, we put what? An equal sign. Are we done with the inequality? Yes. Just write a set notation. How do we write the set notation? Set of x such that x greater than or equal to 5. Yes. The bar? The colon? For me, yes, but from this point forward, since the book is going to be presenting the bar instead of the colon, let's do the bar so that I tell you your noodle gets used to it. Okay? So we're done with the set notation. Now let's do interval notation. What is the left side? Where does it stop or where does it start? At 5. Okay, comma. How about the right side? Does it ever stop? No, so it keeps going to positive infinity. So question, is 5 included in the interval? So it's a bracket. Since we never catch up to the infinity, it's parentheses. Hands if you got that. Okay, good. Let's go to number 2. It says, write the interval 5, 100 as an inequality and also using set notation. 2 things. First, the inequality. This one does have 2 divided points. So the first one is 5 and the second one is 100. That means there has to be a variable in between. What is that variable? X. And let's see. It says that 5 is not included, so I'm just going to do arrow that way. Is 100 included? Yeah, so it's arrow, but with an equal sign. That's the inequality. Let me write the set notation. Solution set of x such that 5 is less than x, less than or equal to 100. Hands if you got that. Yeah, a piece of cake. Yes? We got this. Go to number 3. Write the interval of negative 25 less than or equal to x less than 30 using what? Set notation and interval notation. So set notation, it's easy because they already give us the inequality, yes? So all I do is solution set of x such that negative 25 less than or equal to x less than 30. So far so good? Interval notation. What are my dividing points? Negative 25, comma, 30. Question, is negative 25 included? Yes, so it's a bracket. Is 30 included? It's parentheses. Okay? All right. And last but not least, on number 4, Jake, wake up. Write the interval that as an inequality and all that as an interval notation. So inequality, this is probably the easiest one, right? Why? Because the inequality is right here. Negative 3 less than x less than 5. Next, interval notation. What are my dividing points? Negative 3, comma, 5. Is negative 3 included? No. Is the 5 included? No. And we're done. Hands if you got all 4 of them by yourself. Okay, good. 3 of them. Okay. Everybody got these. Now, for numbers 5, 6, 7, and 8, Hopefully you tried the domain and range, but maybe you struggle a little bit. Don't worry about the endpoints because we're going to talk about that today. So today I'm going to revisit domain and range to clarify a couple of things. All right, here we go. So set that aside, please. All right. So, writing utensils down, let's up to the screen. So I'm going to do a quick exercise so that you guys can understand how your mind needs to focus in regards to graphs and stuff. Okay, so here we go. So I'm going to shade a certain section of that graph, of the coordinate plane, but I'm going to go starting from the bottom to the top. I'm going like this, but I'm going to focus only on the x values because that's going to be my domain. Okay, here it goes. Look at it. All right, but focus, your noodle focus on only x values. Tell your neighbor, from what to what number can we find that shading, please? All right, let's see. Let me zoom in. It looks like from 2 to 8. And if you got that, okay? Now, if I was to ask you to write the domain, what would you do? You would write 2, 8, x, less than or equal to, less than or equal to. You're saying, why equal to on these, Mr. Q? Because that shading is going through number 2. And it's also going through number 8. It's included. Yes. Oh, just numbers individually? No, because now notice that everything's shaded. So, good question. Question was, that's how we write the domain, Mr. Q? Not just 2, 3, 4. What did it see? If I'm shading all this, what does that mean? That I am also including all the numbers in between. What numbers are in between? 0.5, 0.33, 0.45, and so on. So it includes all of them. So we need to write it like that. Yes? Yeah, so I put equal because the 2 is included. Okay? Are you getting there? Yeah? Okay, here goes another. Look at it. It's still domain. Still domain. It's either up, it's going up and down. Focus on the x values. Let me zoom in for those of you that can't see from back there. There it is. Tell your neighbor, between what two numbers can we find the domain of that shading? All right, let's see. Who said from -3 to +3? All right. So, think about it. How would you write the domain as an inequality? Don't say it out loud. Tell your neighbor the domain as an inequality. All right, let's see. Clarissa, go. Hands if you agree with that. Okay. Now, if I really wanted to be technical, look up. What do you guys notice here? Is 3 included? So therefore, if it's not included, what would I do here? Just erase this little thing. You see what I'm saying? I mean, if I wanted to be technical. But for right now, we're going to include it, so. Oh, because if you notice here, there's a little gap between getting to the number 3. All right, let's do one more. Ready? Here we go. Don't say it out loud. Keep it to yourself. I'll zoom in. Think about the inequality. And everybody turn and tell Jake the inequality is falling asleep. All right, very good. You got it, Jake? Got it? All right. Guys, you got to go to bed early, my goodness. All right, so therefore it was -9 less than or equal to x less than or equal to 4. However, if you see that there's a gap, what would you do? Just erase the equal. Are we there? Yeah. Good question. What if I shaded, look up please, what if I shaded like this? Instead of starting from there, let's say, let me do this. All right, let me zoom in. We're still the domain. What would be the endpoints for this domain, everyone? 3.5 and 6.5. So yeah, right now I'm just showing you by exact numbers, but yeah, it could be decimals. All right. So did everybody understand the idea with domain? Okay, now I'm going to range. To range, imagine that you get a big highlighter. We're going to go sideways now. Ready? Here we go. And we're going to focus on the y-axis. Focus on your eyes on the y-axis. Everybody there? All right. I'm going to zoom in. So you never between what 2 points can I find the range? 1 and positive 9. Okay. So that means I can write it like this. 1 and positive 9. What variable goes in between? Y, because now we are using what? Range. Less than or equal to, less than or equal to. Got it? Last one. Here it goes. Don't say it out loud. Think about the inequality. So you know the inequality, please. Let's see. And remember, we're not focusing on X, we're focusing on Y. You nice? All right. What is the range for this one? The range. Javier. What is it? Okay, so it's between -3 and 1. So far you're good. Okay, so what goes in the center? Y. Therefore it's less than or equal to, less than or equal. Andrew, you got that? Okay, so now that we understand how to look for the range and how to look for the domain, now let's use a graph. Yes. Very good question. Let's look at this. Here it goes. Let's say I gave you this function. Look up, please. Is everybody there? Okay, focus, please. Here it goes, because this is where some of you got confused with the graphs last night. Here it goes. I'm looking at this function, and now I'm going to focus on the domain. That means all its values, right? So imagine I ask you to get a highlighter and highlight from the bottom up so that you can actually go through that function. But you're focusing on the domain or its values. Ready? Here it goes. Now do you see the domain? So is this shading touching the entire function? Yes. However, I'm not focusing on the function. I'm focusing right now on the x values that are part of that function. So tell your neighbor from what number to what number is the domain of that function. That is correct. Goes from -5 to +7. Are we there? So our focus should be right there. So that means my endpoints are -5 and 7, so I write x. Since these points are included, then I write less than or equal to. That's my inequality. Do we know how to write in solution sets? Yes. There's my set notation. And an interval notation. Here it goes. Yes? All right. So now that I did the domain, you're going to do the range. Ready? Here it goes. On your paper. Be nice. You're going to write example Q. You don't have to copy the graph, but you are going to write the range. The range. You're going to write range. You can do that in blue. So now we're thinking about a highlighter going side to side. Is that correct? Yeah. All right, so look at it. Think about the y values that are part of that function. Okay, share with your neighbors between what two values of y are we going to find the range? I'll zoom in. There it is. All right, let's see. Did you think about this? Yes. And where does it start? It starts at -2. And where does it end? At 4. That is correct. So therefore, see what it is? You check -2 and 4. What goes in between? Y. The book now started using f of x, so I'm going to use y for right now. And of course, since it includes the points, then less than or equal to. That's my inequality. Write me the set notation and interval notation, please. Go. All right, set notation, you should have written set of all y such that -2 less than or equal to y less than or equal to 4. Hands if you got that. Okay, good. Interval notation, what are my dividing points? -2 and 4, are they included? So that means we're going to use what? Brackets, that is correct. Bracket -2, comma, 4. Hands if you got that. All right. So we're done with these kind of graphs. Now let's get into lines and parabolas. Bam, let's go. All right, on your paper, since you already have graph paper, I want you to graph that, please. All right, so that you guide yourself, look up. My x-axis goes from -3 to 3. My y-axis goes from -2 to 5. And for your line, I want you to use these points as reference. This one right here, that one is -2, -1, and this point over here is 3, 4. So like that, you can draw your straight line through those. Okay, I'll give you some time. Copy that and go. Okay, here we go. So for this one, we're going to find the domain and range. But this is where it gets a little sketchy for some of you. Some of you need to picture it. Ready? Here we go. Focus, please. So if I was to ask you to highlight with the big highlighter from the bottom to the top, a section that's going to touch all this line, all that function that I just graphed. So that means we're going to shade everywhere from here to here. Is that correct? And it's going to go up. All right. So we're focusing on domain. Domain. Okay. So let me ask you. I'm going to start from 0. Is 0, are you going to highlight going through 0? Yes. How about going through 1? Yes. How about going through 2? 3? 4? Wait a minute. Hold on. Hold on. What does this arrow indicate? That it keeps going. So am I going to highlight 4? Yes. 5. Dot, 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 all the way to what? Positive infinity. So the right side of our domain is going to be positive infinity. So I'm going to start from 0 again. We cover 0. Do we cover -1? -2? -3? -4? Yes. Tell your neighbor why yes. It keeps going. So this is what? Negative infinity. And since we're talking about domain, what goes in between? X. That is correct. However, do we ever catch up to infinity? No. So it's just less than and less than without the equal sign because it's not included. I want you to write the set notation of that, please. Set notation and interval notation. Say that again? And a what? Infinity, because it keeps going. All right, set notation. So Solution set x such that negative infinity less than x less than positive infinity, and close. Hands if you got that. Intervals. What are my two dividing points? Negative infinity, comma, positive infinity. They're not included, so we use parentheses. Yes? I'd rather you put the negative on the left side because negatives go to the left. All right? All right, now that we're done with domain, let's see if you can actually write the range. Let me move this out of the way. I want you to write range. All right, so now we're going sideways. We're going to get a huge highlighter and highlight all the section for y. So question. Oh, here it goes. Let me show you kind of like where we're at. We're highlighting that way. Is that correct? So let me start from 0. Is it going to go through 0? 1, 2, 3. So what would be the right side of my range? Positive infinity. That is correct because it keeps going. And right now I'm focusing on the y. Is that correct? Okay. So we said that 0 is included. Is negative 1 included? Negative 2. Negative 3. Yes. Why? Because it keeps going. So the left side would be what? Negative infinity. So what goes in between? Y, and then less than and less than. Write me the set notation and interval notation. Okay? Solution set of y such that negative infinity less than y less than positive infinity. Notation, negative infinity, comma, positive infinity, and they're not included, so it goes with parentheses. So we were saying how confused you are with this so far. Got some 4s, 5s, 4s, 5, 4s, 5. Let me have need a pedicure. All right. All right. So now that we covered that, I'm going to zoom out. Check this out. Now I'm going to talk about end behavior. End behavior. Writing pencils down, look up to the screen. Here it goes. I'm going to focus on the domain. Here we go. So the domain. Here it goes. I'm focusing on x. This is x value of 1. When you go to the line, what is the value of y? 2. Next, x value of 2. When you go to that line, what is the value of y? 3. X value of 3. When you go to that line, what is the value of y? 4. So if I continue going that way, what can you conclude about the y? It's going to keep going. So therefore, we write it like this. As x goes to positive infinity, comma, what should I write? Y goes to positive infinity. We got it? Okay? Thank you. Look up, please. All right. So I went that direction. Question. Look at negative 1 of x. Y is 0. Negative 2 of x. What is y? Negative 1. Negative 3 of x. What is y? Negative 2, and so on and so forth. So as x approaches negative infinity, what can we conclude? Y approaches negative infinity. And that's how we write the endpoints. Okay? All right. Next. Look at this one. Don't copy this one, just pay attention. We're going to focus on the domain and range. Ready? So, domain. Can you picture the highlighting all the way up? Do you guys see that? Yeah. All right. So, is 0 included? Is 1 included? Is 2 included? Is 3 included? Yes. Why? Because this one indicates that it's what? So the domain to the right side is to positive infinity. So what can we conclude on the other side? Negative infinity. So it's x less than, and less than. Okay, so here's where it gets tricky. I'm going to go to the range. And I'm going this direction. All right. Is 1 included? 2, 3, 4. So therefore I could conclude that all the way to the right is what? Positive infinity. However, is 0 included? Is negative 1 included? No, so what would be my other extreme? 0, so this is y, less than or equal to, and less than. Tell your neighbor why this one is equal to, please. Yeah, because this graph goes through 0 and it's included. Okay, we got it? All right, last but not least, look up, please. Copy this one. Example, Shazam Q, graph f of x 3/4 x plus 2 with a domain of -4 and 4. So, if they were asking us to graph this, because your home plate is going to have a parabola, check this out. Look up, please. My domain is what? From -4 to 4. Is that correct? So if I was to make a table, -4, what's next? -3, -2, -1, 0, 1, 2, 3, 3, 4. But what do we know? That it isn't this a straight line, guys? Look at it. Yes. So do we need the whole, all those points? We just need what? The -4 point and the +4 point. So what do we do? How do we plot it? Substitute. We're going to substitute this -4 in there to get the y, and the +4 in there to get the y. Everybody see what I'm doing? So I'm going to start with this one, -4. So I write y equals 3/4 x plus 2. I change it to y because some of you get confused with f of x for right now. So y equals 3/4 times -4 plus 2. Y equals -3 plus 2. So this is -1. So my point is -4, -1. And if you substitute this one in there, that gives us 5, which is 4 and 5. And that's how you graph your function. Grab a play sheet for your home play for tonight? No, I'll find it right now. The student, if I don't see you guys tomorrow. Bye.